So in our today's lesson, we are starting at exponential equations, and we need to ask ourselves what is an exponential equation. So an exponential equation is simply an equation of the form 3, simply an equation of the form 3x equals to what? 81. It's just a form. You can even have a to the power x equals to b, where a and b are what? Where a and b are real numbers. So how do we solve these exponential equations? So to solve exponential equations is it's not something that is difficult, it's something that is easy. So let's get to our example 3.2. Let's get to our example 3.2. And example 3.2, the first question, which is A, requires us to find the value of x when we have something like that. So the first thing that we need to do in order for us to solve this is as follows. Let's try to check. Is there a way of expressing 81 into 3? Because we can't express 3 in terms of 81, but we can see, is there a way? So first of all, that's what you need to do. Ask yourself, can we rewrite 81 in terms of 3? So in this case, yes. So 81 is the same as 3 to the power 4. So we have 3x, which is equals to 3 to the power 4. So now that this piece and this piece, they are both of the same base. And the base here is 3, even there is 3. So the same bases here can now cancel. And we remain with x equals to 4. Meaning that 3x equals to 81. The value of x is equals to 4. So that's the first case. Now the second case, B here, we have 8x, which is equals to 0.125. And here we also do the same. So we can rewrite, first of all, the decimal number into a fraction. So 0.125 is as good as saying 125 divided by 1,000. Divide by 1,000, and then this is equals to 1/8 if you simplify this. So 1/8 here is the same as, for example, 1/8 is the same as 8 to the power -1, laws of indices. So in short, we now have 8x, which is equals to 8 to the power -1. So now 8, we have the same base now. This is in base 8, even this is in base 8. So we can easily do the cancellation here and remain with what? X equals to -1. That's for the second part. So we will look at, let's move to E. Let's move to E. E, or before E, we move to D. D, it was 3x plus 3, open bracket, 2x minus 4 equals to 0. Minus what? Equals to 0. So in order for us to solve this question, there are just a few things that we really need to take into consideration. So here, when we look at this, here we have 2x, but here we have 2 to the power 3x. But 3x is the same as 3 times x, meaning that 2 to the power 3x is the same as 2 to the power x multiplied by 3, of which you can put this in brackets like this and say 2x, 3 like that. So that's how we are going to rewrite this piece. So this piece, you rewrite it as 2x to the power 3 plus 3 2x minus 4 being equated to 0. So now you have this value here, which is 2x, 2 to the power x, and this is 2 to the power x. So it's quite cumbersome to continue solving with this here when you can just let. So instead of going with 2 to the power x, let's let it be equals to some value, some variable. Let's say y, let's say p, any value of your choice. So if we let 2 to the power x to be equals to y, it therefore implies that in this our equation, we are going to have y to the power 3 plus 3y minus 4 equals to 0. So we now have a cubic function, and we are required to solve a cubic function. I'm pretty much sure you still remember how to solve a cubic function. So for a cubic function, you first of all need to look out for values like factors, which value of y, such that when you plug it here, you obtain a 0 at the end. So that's how we start. So in this case, when we let our y to be 1, when you let y to be equals to y here, when we plug a 1, so we have y to the power 3 plus 3y minus 4 equals to 0, and we are letting y to be 1. So we plug a 1 there, plus 3 multiplied by 1 minus 4. This is going to give us a 0, meaning that y equals to 1 is one of the zeros, and y minus 1 is a factor. So since we have found one value, we can therefore move to using either long division or synthetic division to find the other factors. So if we move to using synthetic division, so using synthetic division, remember this part here is this, you use the actual value of y, which is 1, and here there's multiplication, and then we go back to our function, y to the power 3y minus 4. So this has to be written in order. So the highest exponent here is 3, meaning that from 3 the next was supposed to be 2, and then 1, then later on the constant term. So this has to be rewritten. So you're going to have y to the power 3 plus 0 y squared plus 3y minus 0, and get the coefficient. So here our coefficient is 1. The coefficient for y squared is 0. For y is 3, and the constant is 4. Like that. The next, we have a plus sign here, and we drop the first value here, which is 1. Then we start 1 times 1, the value is 1. 0 plus 1, the value is 1. 1 times 1, we are getting a 1. And then 3 plus 1, it's a 4. And then 4 times 1, it's 4. Now what is negative 4 plus 4? It's 0. So already that 0 there is the remainder. So these values now are the values for our second equation. So we are coming from an equation whose highest exponent was 3. So meaning that this equation that we are going to form here, its highest exponent is going to be like y squared. So this is the coefficient of y squared. That is the coefficient of y, and that is the constant. So you just add these to come up with a new equation. So our new equation, which is q, I like using q of x to mean for our new equation. And then it is y squared. It is 1 multiplied by y squared plus y multiplied by 1. And then the constant, you use a 1 to multiply the constant, plus 4. That's what we have. So now our original equation is going to be this part here multiplied by the factor, which is y minus 1. So let's look at this equation. So when you just look at this part here, sometimes it's good to check using your discriminant. Can you proceed in solving this quadratic equation and be able to obtain the values which are real values? So you can use discriminant. So discriminant here is b squared minus 4ac. So our b here is 1, you square it, minus 4, our a is 1, and our c is 4. So we have 1 minus 16. So our answer here is negative 15. So when the discriminant is negative, meaning that we are not going to have real solutions. So therefore, for this quadratic equation, we are not going to have real solutions. So the only real solution that we have for this cubic function is y equals to 1. That's the only real solution that we have. Since the value of y has been found, if we now go back to our original equation, y was what? Y was equals to 2x. And now the value of y that we've calculated is 1. So where there is y here, you plug a 1 and you have 2 to the power x. And what do you think happened for this part here to be 1? Meaning that it was a number the number that was raised to the power 0, and that number should be similar to this number here. It should be of the same base. So it will be 2 to the power 0, which is equals to 2x. So now that they are of the same base, you can cancel this, you can cancel out that. Therefore, x is equals to 0. That is the value of x for that given equation that we were looking for. Unless there's a question before I move to E, let me pause here. I hear if I the questions. In case you have any question, you can just drop it in the chat box and I'll be checking the questions. But for now, if I thought there's anyone with a question, you can ask before I proceed to E.
I have a question, madam.
All right.
When you use y is equal to 1, like, are we always supposed to use 1 first, or?
Okay. So when you go back to this part here, we said when solving a cubic function or a value or any equation, starting from any equation whose highest exponent starts from 3.5, you have to look out for a value of y that you put in this function in order for you to obtain a 0. That's what you do. So it's not every time only it's a 1. Sometimes it can even be 5, it can be 2, depending with what is going to give you a 0, because that is your starting point each and every time. You need to look out for which value of y are you going to put here in order to get a 0. And once you find that value, it's one of these, meaning once you find that value, it's the one that you are going to use. So in this case, we are lucky, y equals to 1 has worked here. It has given us a 0 here, meaning that it's one of the zeros, and the factor here, it is going to be 1 minus 1. So it's not always a 1. Let me just say it's not always 1. It depends with the value that has given you a 0 after plugging in the equation, because that is your starting point. Any other question? Is it clear?
Yes, it's clear, madam.
All right.
Thank you.
You're welcome. Okay, let's move to the next question, which is E. So E is 4x, 4 to the power x, minus 2x plus 1 equals to 8, like that. So we are again required to solve this question. So it's not something which is it's not something different from what we are just from solving. So you just have to find the means of rewriting. For example, you write this one in terms of 2, so that we have something, we have common terms. So 4x, if I start with 4x, in terms of 2, 4 is 2 to the power 2, that is 4. And this has to be to the power x, like that. So you can rewrite this and say 2x And 2x is the same as 2 to the power x. 2 to the power x, and this has to be squared. So that's what we have here. So this is going to be 2x and squared minus. So when we come to 2x plus 1, laws of indices, for us to add the power, for the powers to be added like that, the initial equation was 2x multiplied by 2 to the power 1. So this is the same as 2 multiplied by 2x. So that's what we have here, 2 open brackets 2x equals to 8. So now you're saying that here we have 2 to the power x, even here we have 2 to the power x. So we can again can use any value, any variable. You can even use p, you can even use a, depends with what you want. So in my case, let me just use y. So let y to be equals to 2 to the power x. So in this equation, whenever there's 2 to the power x, I'll put a y. So if I put a y here, it will now be y squared minus 2y is equals to 8. So we now have a quadratic equation, and we know, so for us to solve a quadratic equation, it has to be equated to 0. So this 8 has to be brought to this other side. 2y minus 8 equals to 0, like that. So we solve the quadratic equation. So when you solve this quadratic equation, you can check your notes nicely. You discover that the values of y that you find here is y equals to -2 or y equals to 4. So we have found the values of y, but we are not looking for y, we are looking for x. So we need to go back to this part here where we said where we're letting y to be 2x. So y has been found to be 4. So put a 4 here and solve for this. Similarly, y has been found to be -2. Put a -2 there and solve. So let's start with the first case. So y is equals to 2x. And the value that we found for y is y equals to 4 for the first part. So when you put a 4 here, where there is y equals to 2x, we now have an exponential equation that we need to solve. So we can easily write 4 in terms of 2. So 4 is 2 squared, which is equals to 2x. So this and that part cancels. Therefore, x is equals to 2. So we found for that one. Now we move to the other value of y, which is -2. So y is equals to -2. So when you put -2 here, equals to 2x. You cannot, once you have a negative here, simply we can't have a logarithmic function we can't have a negative logarithmic function. Log of any negative value is undefined. So here, this part here, when y is -2, we're going to discard this because this one will discard. We can't have a negative values, discard. So therefore, the only solution for this is x equals to 2. That's all. So that was about it. Unless there is a question, any question? Any question? Okay, since there are no questions, let me solve this.